Let's go ahead and look at an example where we create a frequency table for quantitative data. So we're going to still be looking at counting the number of times something occurs, but remember that quantitative data are measurements. So we're not going to have this limited number of categories where, like the ice cream example, chocolate, vanilla, mint chip, etc. We're going to have to find a way of taking these measurements and putting them into their own sort of classes or groups. So suppose we have a medical clinic that records the pulse rates of 27 randomly selected patients. So we take all of this data, and the first thing we want to do before we put it in a table is we want to order it from least to greatest. And one of the easiest ways to do that is to put the data into like a program like Excel or StatDisk and use their sorting feature. The second thing that we're going to do is we're going to choose the number of classes or categories that we want. So just like I said with the ice cream, we're not choosing vanilla, chocolate, mint chip here. We're having to find a way to categorize all of these different pulse rates so that we can actually put them in a finite table. So I'm going to choose 5 classes. So in other words, I'm going to have like 5 ice cream flavors. I'm going to have 5 ranges of pulse rates here. But that's up to you. This is a choice. 6 would be sufficient as well. The third step here is we want to find the class width, and to do that we're going to subtract the lowest data value from the highest data value and divide by the number of desired classes. So this is going to give us an approximate class width, and then we're going to just round as we see fit. Carefully not to round down because that might eliminate some of our data values. So let's look at what this looks like for our example. If you look back on the previous slide, the highest pulse rate was 119 and the lowest pulse rate was 55. So we're effectively finding the range in the pulse rates here. And then I'm going to divide that difference by 5. And the reason I chose 5 was because that's the number of categories I want in my table. And when you do that, you get the decimal 12.8. So we're going to round this up to 13. We don't want to round it down because we might miss out on some of the data values. Our classes might not encompass all of the data values. So rounding up to 13 here works. There's no rule that says you have to round to a whole number though. A decimal would be fine. If we really wanted to leave this at 12.8, we could use a class width of 12.8. It's just nice to work with whole numbers. The fourth step is that you want to go ahead and start building your table by first defining your lower class limit. And so you're going to choose a value that is the lowest number in your data set, so maybe like 55, or even something lower than it would be fine, as long as you know that your class width is big enough. So we're going to go ahead and use 55, which is the lowest number in our data set. And then now we're going to use our class width to obtain consecutive lower class limits. So we're going to take 55 and we're going to add 13, which was our class width from step 3 here. So 55 plus 13 is 68. 68 plus 13 is 81. 81 plus 13 is 94. And 94 plus 13 is 107. So we have obtained all of our lower class limits. And so then the fifth step here is to get the upper class limits. So if this class starts at 55 and this class starts at 68, what's the number below 68 that's going to end the previous class? Well, that's 67, or maybe it's 67.5, but it's a number that is less than the beginning of the next class. So what you'll notice is that there's no overlap of numbers in these classes. And the other thing is that each class is of uniform size. So the range from 55 to 67 is 12. The range from 68 to 80 is 12. So these are all uniformly 12 spaced apart. Now remember though, 12 is not the class width. 13 is the class width. And the class width is the difference between consecutive lower limits or even consecutive upper limits like 67 and 80 or 80 and 93. So we've built our classes. Now it's time for us to go ahead and find the frequencies. So once we have that information all listed in numerical order, it's easier for us to count how many of these pulse rates fall within each of the classes we created. So when we look at the class from 55 to 67, we can see that there are 1, 2, 3 data values that fall within that class. When we look at 68 to 80, we can count 9 data values that fall within that class, and so on. So what if we would have just made a couple of different choices in that process of building our frequency table? Supposing we have the same number, same data here, but instead we would have chosen a class width of 12. And let's go ahead and go start our lower class limit at 55. So if the class width is 12, it means I'm going from 55 to 67, 67 to 79, 79 to 91, 103 to 115. Now, that's going to shorten this distance here. So 55 to 66 here is 11. And then my next class starts at 67, and then it ends at 78, and then 79 to 90, etc. So you can see when we count our frequencies for each of these classes, we get slightly different values. The other thing you'll notice is that because I shortened my class width to 12, I now have 6 classes listed in this table. And so those 6 classes are more than my previous example. I only had 5 in the previous example. And the reason I had to do that was because I rounded that 12.8 here down to 12, which forced me to add a final class in order to encompass that high value of 119. Here's another example of some just different choices. So again, using a class width here of 13, but suppose I chose my lower class limit here to be 54. So I'm going lower than the 55 of my data and going down to 54, which is totally allowed. So 54 plus 13 to 67 plus 13 to 80 plus 13 to 93 plus 13 to 106. But then that puts the end of that class only at 118, because remember, these all have to be uniform width here, right? And so I'm ending here at 118, which omits this 119. So what that means is I really need to, again, add another line here, another class, in order to encompass that last data value. And, again, you can see here we have this slightly different frequencies because I changed where my classes reside. One more example here, just showing that you can use decimals. I'm going to keep a class width of 13 with this example. My first lower class limit, though, I'm going to start at 54.5, right? Because that's a decimal that's less than 55, but it's not a part of 54. So we're starting at 54.5. If we add 13 to that number, we get 67.5. Add 13, 80.5, etc. And so then that means we want to end each class with an upper class limit that is just a little less than the beginning of the next lower class limit. So if my next class here starts at 67.5, it makes sense for me here to end this class at 67. Or if I wanted to go even further with the decimals, maybe I get up to 67.49, just before 67.5. So there really isn't a gap in between. It just really depends if you want to use decimals or not, if your data is useful with decimals. So in this case, we're talking about pulse rate, and we don't typically talk about pulse rate in terms of a decimal value. We generally use whole numbers to describe pulse rate. So just a little bit of a recap here of all the vocabulary we used in that example. A lower class limit is the values that begin each class. So these on the left here are the lower class limits, 55, 68, 81, 94, 107. And the upper class limits are the values that end the class. So these are the 67, 80, 93, 106, and 119. The class width is the difference in consecutive lower or upper class limits. So it's not across the class, it's up and down here. So it's 55 and 68, or a difference of 80 and 67. The class boundary is the value that separates each class. And I didn't actually even mention that, but like in this case, if this class ends at 67 and this one ends at 68, maybe the number right in between 67.5, in between 67 and 68, that would be the class boundary. And then the class midpoint, here's something new. The class midpoint is the value in the center of each class. So to find the midpoint, the easiest way to do it is to take the sum of the class's limits, so the upper and the lower, and divide by 2. So in this case, 55 plus 67 divided by 2 gives us 61. 68 plus 80 divided by 2 gives us 74, etc. The other thing you'll notice is if you find the first class midpoint, each class midpoint is spaced a class width apart. So the difference between 61 and 74 is 13. The difference between 74 and 87 is 13.